Using trigonometric identities. In this video, we're gonna use the identity sine squared theta plus cosine squared theta equal 1. First, we're gonna prove these identities by using the triangles. So you have the right triangle with 3 sides in one angle like this, and we know that a squared plus b squared equals to c squared because it's a right triangle. And if you divided both sides by c squared, you're gonna get the identities we're using today. Sine squared theta plus cosine squared theta equal 1. Another way to prove is you're gonna use the unit circle. So on the unit circle, you know the x is gonna be equal to cosine, the y is going to be equal to sine, and the radius is going to be equal to 1. So you draw like here, you're gonna see that to the right triangle and x squared plus y squared gonna be equal to r squared. Or in other words, sine squared theta plus cosine squared theta equal to 1. So that is two ways to prove these equations. Using the equation identities to apply to problems. So I have one problem right here. 1 plus sine squared theta over cosine squared theta. So we have the denominator is cosine squared theta. I'm trying to make two of the term to have the same denominator by making this one make up the number 1 right here to be cosine squared theta at the top in the denominator and cosine squared theta in the denominator as well, so that they're going to be equal to 1. And plus sine squared theta over cosine squared theta, keep it the same. Then we know that sine squared theta plus cosine squared theta is going to be equal to 1. So that's why I put 1 over here, and the denominator is the same. And simply simplifies to secant squared theta. So this one right here is when we apply the identities to our problem. Alright, so number 3, gonna expand the equations. So we have the parent equation. From that equation, you can expand them to two more equations. Is sine squared theta equal to 1 minus cosine squared theta, and the second one is cosine squared theta equal to 1 minus sine squared theta. So they are pretty much the same, but I just expand them for my equations. And I'm going to apply that to one more problem right here. So we have secant squared theta minus sine squared theta over cosine squared theta. So we know secant is 1 over cosine. So secant squared theta is going to be equal to 1 over cosine squared theta. And I keep this over here the same thing. Except for this, we know that 1 minus sine squared over here. 1 minus sine squared theta is going to be equal to cosine squared theta. So that is why the reason I put cosine squared theta over here. And the denominator keeps the same. So right here you have the numerator and the denominator the same. So they're going to be equal to 1. And that's it. That's it.